Record to the cloud. All right,
Thank you.
we are
Yeah, thank you.
recording. Um, so again, I'm gonna post this PDF once we go through all of it. So if you miss a number, don't worry. But as far as the means of construction go, I kind of want to explain the different components so that instead of just copying and pasting the notes, um, you're starting to get an understanding of what we're calling out and the reasoning behind calling out these components in the wall sections. So again, per the instructions, they're ordered in a fashion that if we start at the top of the wall section and work our way down, we start with one, note one, and then we can kind of trace our way down the wall section and assign these notes accordingly. When you're in an office environment, most likely you'll be given a section to reference that you'll implement certain notes from that section into whatever project you're working on. But it's good to have an understanding of what you're copying over because not all elements may be applicable um, to a construction detail. So while most of the time you will be copying over information from one to the other, you will want to have a general understanding of the means of construction or method of construction. So we're going to look at the wall section. And the first component that we have here is pre-finished metal fascia on PT wood blocking. The PT stands for pressure treated. This essentially is telling us that the wood is treated in a sense that it won't be subjected to moisture damage. And because it's close to being exposed to the elements, you want to make sure that it's treated in a sense that no moisture getting in there is going to cause the wood to rot over time. So what this pre-finished metal fascia on painted wood blocking is referring to, it's going to be this component here that I am highlighting here. So it's this full assembly here, and it's a cap that goes over your parapet wall. And what is happening is we have a roof membrane that is aligned on top of the roof. It's going to come up the back side of the parapet wall, come over top of the parapet, and then down. So this metal fascia goes on top of that membrane to protect that membrane and prevent any moisture from coming up and around this parapet. The steel tube is pretty self-explanatory. So we have a steel tube at the top of the structure. Depending on the type of construction you have, you may just have a channel, a light gauge channel at the top. If you have a large wall, such as a double-story wall like this, uh, there may need to be reinforcements. So what we see here is a steel tube. Your structural engineer should be specifying this information. So if they do not provide it, then it probably means that you don't need it. But most of the time, you'll see a steel tube at the top of your parapet wall, as shown here. And this is, of course, we're talking about light gauge metal construction. So if you're dealing with a wood construction, these details are going to be slightly different. So this is obviously uh, specifically for a metal building. As I was mentioning before, the fully adhered roofing membrane on 5/8 exterior sheathing, extend membrane up and over parapet. So we're thinking when we're talking about this note, we're talking about how we're sealing the building. So on the roof, we have essentially this plastic cover. It's really a membrane that can be fluid applied, uh, but it is a layer of protection that is going to be laid on top of the roof and then extend up your parapet wall and up and over. And that way, if any water lands on your parapet or lands on your roof, it's going to simply just go down and follow the slope of the roof and not seep into or underneath of this membrane layer. The fourth note, pointing to the top of the roof itself, is the fully adhered roofing membrane. So the reason why we differentiate 3 and 4, 3 is specifically instructing the general contractor to wrap the membrane up and over the parapet. Our note number 4 is talking about the membrane on the roof system, and then the rigid insulation value of the roof, and then the substructure or substrate, which is 1.5-inch metal decking, which is this white region that's underneath of the rigid insulation. So that is this note pointing to the top of the roof. Our note number 5, the steel joist and beam, which says to refer to structural drawings, because this is going to be incorporated in their drawings, and these members are going to be specified, the sizes are going to be specified by your structural engineer, but it is the structural components of your roof system. So we want to make sure we're calling out any members that are seen in the wall section there that refer to the roof structure. So we're calling out the steel joist and beam. So we have our joist member and we have our beam member. As far as detailing those actual components, we have what I have placed in here is a W24 by 76. And then the K series bar joist is an 18K6 series. So you can find them again by going to the Insert Load Autodesk family. We want to go to our detail items. We're going to go to our metals, because that is where a lot of the steel elements will be located. From here, we have already narrowed down our search result. So for the wide flange, we go to the W and we find our W-shaped section here. So you'll be able to click on that and then find the specific size member that I had mentioned. And then the same is going to go for your joist. We're going to go up to the K. We're going to see this K series bar joist side. You want to make sure it's the side and not the section, unless we're cutting through the section, but we aren't in any of these scenarios. And then you want to just click on this and look for the 18K6. So that explains detail item 5. Number 6, we have a 10-inch metal stud with batt insulation to 6 inches minimum above roof. So this has 2 components in it. It's telling us the thickness of the structure of the wall. So we have the 10-inch metal studs. So that is essentially saying this width here, we are looking at a 10-inch stud. And we have batt insulation. So this is our thermal insulation. That is the full width of the size. So again, if we want to annotate insulation, if we go to the annotate tab, you will see an insulation. You'll see an insulation detail item. You simply click it. Under the properties, you can change the width of it. So most of the time if you are working with metal construction on an exterior shallow building, you're going to be looking at 6 inches, sometimes 8 and sometimes 10, depending on the design of your facade. But you simply type in your insulation width and then you can trace it as needed and locate it within the stud. So the 2 components, we have the structure of the wall with the light gauge framing, which is the 10-inch metal stud. And we have the batt insulation, the full thickness, and we extend that 6 inches above the roof. And this essentially just guarantees that there's no leakage of or a thermal bridge between where the roof meets the stud. So any,
So so for
yes.
the insulation, how do I get the rigid insulation to show up again?
Okay, so if your section looks something like this, is this kind of what it looks like? I mean,
Yeah,
minus
yeah.
all.
It just doesn't have
So
the rigid insulation
so
on.
all of your sections should be at fine detail. So there's two ways we can go
Uh,
about changing this. If you are in your section view, under the
mhm.
properties tab, you will see this detail level. You can drop it down and click fine.
Oh, okay.
The other way you
Uh,
can quickly do it is
yes.
just go to the bottom of the screen where there's like the sunglasses, the light bulb. There's most likely a empty rectangle. If you hover over it, it'll say detail level, and you just click that and click fine, and um, that should enable the full visibility of your wall section.
Okay.
One
Thank you.
thing, one thing to note, this is fully seeing all of these elements within your wall. So if I were to, let me fully expand my Revit model real quick and go to my project browser. So if I were to create a new wall section, um, so note that this assembly that we are seeing here, this is fully based on the type of wall that you are modeling. So if I go back to my floor plan, and let me actually go to a working plan real quick. Um, so if I create a generic wall, which it doesn't look like there's one in here, but there's a 12-inch concrete wall. So I'm gonna use this as an example. So I just placed a 12-inch concrete wall. If I change this to be a brick with metal stud, sheathing, and rigid insulation, and change this to fine, we can see that the different layers are created. And then we are going to create a wall section through this so that we can understand what's going on. So this is the information that's being shown in that section is fully dependent on the wall that you are creating. So if I were to click on this wall and hit edit type, you guys should be familiar with this at this point with your Revit class. But if we go to the edit tab after modifying the edit type of the properties, uh, you'll have an assembly that gets opened within Revit. And this is where you are telling the construction of the wall assembly that you're using. So we can see the structure here. We have a 6-inch metal stud. And then we have a substrate of a 1/2 inch gypsum wall board. We have 1.5 inch rigid insulation. We have an air barrier. In our office, we try to, because you're supposed to model things as their actual size. So brick as a modular coursing is actually 3 5/8, not 4 inches. We try to model the airspace so that the total thickness of the wall is a full value and not a fraction. So that's why we're seeing this 1 3/8 here rather than like a 1 inch or 1.5 inches. Um, but if I were to go to this concrete assembly here and I go to edit type, we just see a 1 foot thickness of a unassigned category. Ideally, if this is actually a concrete wall, we're giving it a concrete value so that I can hit okay, okay, okay. But now you can see it's affecting the filled region or hatch pattern of that wall assembly. So because in this instance, we have a linked model that has the wall already assembled for you, it's going to be much easier and we should be able to just see we have the metal stud layer with the batt insulation. We have our layer of sheathing. We have our rigid insulation. We have our airspace, and we have our brick. Okay. Number 7's pretty straightforward. Number 7 is our 4-inch face brick with airspace and 1/2 inch continuous insulation on fluid applied membrane on the exterior sheathing. So this is a general note that we can kind of just point towards the wall assembly, but because the first thing we're calling out is the 4-inch brick, you want to try to leave your arrowhead more or less over the brick region, because everything else after that is then following that assembly. So we know from this language here, we have a 4-inch brick, airspace, rigid insulation, fluid applied membrane on exterior sheathing, and then per note 6, we have a 10-inch metal stud with batt insulation. Our next note here, which is note number 8, so working our way down still, we have a steel tube with brick angle. So your brick is going to need to be supported by a lintel. Here, the way we have our lintel constructed is we have a steel tube that's supporting the studs above, and then we also have a steel angle that's most likely welded to this tube. And this steel angle is acting as our support for the brick above it. So our steel tube and angle should be able to point in this general direction at this angle. For your reference, this angle here, I currently have it as a L6 by 6 by 1/2 inch. That should already be in your model. You shouldn't have to add that in from the construction cloud. But if you do, again, it's just under the insert load Autodesk family. When you do detail items, metals, it's this first one that you'll see is the AISC angle shapes section. So you can just simply click on that and then find the correct size, which is the L6 by 6. The thickness of the member shouldn't matter too much because your structural engineer should be calling that out. If possible, you want to try and place this as accurate as possible, just so that you can be coordinated as closely as possible. But the big things that matter in this situation are the depth. So making sure that we're the 6 by 6, and then the thickness is going to be called out by your structural engineer. Can anybody tell me what a storefront system is?
It's just a fenestration system used. Arset.
So yeah, so storefronts are it's a way of glazing. So if I were to type in storefront, it's most of the time it's going to be in like commercial architecture, but you can get it in office environments or other classroom environments. It's a little different than a curtain wall. So storefront can only span a certain height before you need to resort to a curtain wall. Curtain walls require more structural support, whereas storefronts are a little more self-supportive. But storefront essentially is this glazing system. So we have our storefront mullions with a glazing that gets inserted into the channel. So we go to like a storefront section, we can see different methods of so we can see here assembly. So you can see this is the storefront system. And then the glazing gets inserted into this clip, both above and below, and then even the jambs, so the sides, and they get inset and supported by the storefront system. So as far as our wall section goes, it's an easy note. We're just going to simply call out storefront, being this fenestration or glazing. Our next note, which is number 10. We have a concrete slab on metal decking, and I have this note as being the interior second floor. So pretty straightforward. Concrete slab on metal decking is referring to the concrete component in this assembly. Same thing for note number 11. We have an exterior deck that is a concrete assembly on a metal deck. So this is going to be our note number 11. And with our deck, you can see that we have a floor at 16 feet, but our deck slopes away from the building. That's making sure that no water is pooling on top of the deck and then seeping into our building. So we want to have positive drainage away from our building. And that's something that's specifically detailed and drafted on this section. Any questions so far about anything that I'm going through? Okay.
Okay.
Oh.
Right now I'm trying to find another thing to put in here. I believe it is a 4-inch CMU, but I do not know how to find it in the Autodesk family.
So you're referring to a 4-inch CMU?
Yes, because in the building section, right
Oh,
beneath the brick,
right
there-
here.
I believe, yes, that thing.
Okay. So the way we are going to model a 4-inch CMU, you'll see under the annotate, let me do full screen here. So if I go to annotate repeating detail components, there's going to be an 8-inch CMU in your model, most likely. If you were to place that a wall, you can see that we have an 8-inch CMU. So in order to get this to be 4 inches, we need to do something to modify the element. When you place your 8-inch CMU, you want to hit edit type. You're going to want to duplicate this, and you're going to want to click or change the name to 4-inch CMU. I'm leaving the 2 because I already have a 4-inch CMU in my model, and you can't have duplicate values. So once you duplicate it and rename it to 4-inch CMU, under the pattern, there's a detail category. And if you drop that down, you should be able to see
A detailed category. Oh, here we go.
So do you see a area that says 4 by 8 by 16 CMU2 core section 4 by 8 by 16? So you want to click that, and if you hit OK, you can see that changes it up to a 4-inch CMU, which is actually 3 5/8 because it's masonry.
Yeah, but nominal is the thing we're looking for right now.
Yep.
Okay.
All right. So notes 12 and 13 refer to the steel structure. So it's pretty straightforward. They're both the same, but for 12 we're referring to the inside, whereas 13 referring to the exterior deck support. They are the same annotation note, so it really doesn't matter which one's which because they are the same language. But 12 and 13, I'll keep it consistent. I'll do 12 and 13 for you. Our next item, we have a linear metal soffit. Who knows what a soffit is?
I believe the soffit is the part underneath of the like overhang.
Correct. Yeah, it's essentially your ceiling system. So when we say a linear metal soffit, we're talking about this ceiling, linear metal ceiling, or linear metal soffit. That's the ceiling, exterior ceiling, but it's the finished material of underneath the deck above. So all right. So the next item we have here, we have brick ties at 16 inches vertical and at 8 inches, I'm sorry. So brick ties at 16 inches vertical and at 8 inches vertical above roof. So what this is referring to, I'm going to exit out of my thin line mode so we can see what exactly we're talking about. So the brick needs something in addition to just the angle support to be structurally sound as part of your wall assembly. So what it's typically used is called masonry ties or brick ties. And graphically, it is these elements here that are spaced 16 inches on center. And they are located at the grout joints of the brick. And essentially, what we are doing here is you stack your brick or lay your brick. You provide a brick tie that is tied back to the structure of your wall assembly. And then you start to lay brick on top of that. You go up 8 courses, which is 16 inches, and then you lay another row of brick ties. And this is essentially tying back your brick facade to the building itself. So when we say masonry ties or brick ties at 16 inches on center, these are the components that we are talking about. As far as the graphical representation of these, I have these just modeled as lines. So they're with a thickness of 5, and you just want to have the line be more or less 3 to 4 inches in vertical length, and then at least spanning halfway into the brick course. So here I have about 4.5 inches.
I believe they. Oh, sorry. Okay, I believe they also have a brick tie in the actual thing. Like if you
They do have, if you choose to go the route of the annotate repeating detail component, you can also see you can see them located here, and you can use these families as well. But make sure that once we get above the roof line, you can see that it switches from 16 inches on center to 8 inches on center, which is every 3 brick courses. Any questions regarding masonry ties? All right, let me keep going. So I'm gonna copy this, bring this down to 15. Then we have note number 16 is pretty self-explanatory. So in this area, we do not have a 10-inch metal stud but we instead have a 6-inch metal stud. So we are simply calling out the difference in the thickness of the light gauge material. And we are still saying with batt insulation, the full thickness of the stud. Note number 17, we are simply repeating ourselves with the assembly of the wall. So we are saying 4-inch face brick with the airspace, continuous insulation, membrane, sheathing. And the reason why we're repeating ourselves here is just because there was a break in continuity. So we call out the material up here as brick. And you don't necessarily need this, but it's good practice to have just that continuity so that when it's interrupted and we go down to the floor below, we're just calling this out as a brick material. Again, who can tell me where this note 18 is going? So we have a steel tube with brick angle. So steel tube with brick angle. I'm gonna like hover around. Somebody just say stop when I hit the steel tube with brick angle.
Stop.
Yeah. So our steel tube with brick angle is here. And again, this is the same function as above. So we have our steel tube and our lintel that's supporting the brick. We still need to support this brick. So we have this structure here that is supporting this brick up to this joint here. So we are calling this out as note number 18. We're pointing to there. And we know what our storefront is at this point, yes? So this is our storefront system, and we're just specifying that they are to provide the head and sill receptors. And that's provided by the storefront manufacturer, and storefront head and sill receptors are referring to this element here. So the head is where it's meeting the adjacent condition above, the sill meeting the floor below. And what you don't see in the section is the jamb, which is the sides. All right. So we are now on to the easy part, which I'm not giving you the answer for until you guys tell me what's what. 20 concrete slab with vapor barrier on gravel subbase. Who can tell me what this is?
Foundation system used.
Yep, so this is going to be our concrete slab with the vapor barrier underneath of it. So this vapor barrier is right underneath, and it's going to go and wrap down. And this is going to be note number 20. Does anybody know what a 1/2-inch expansion joint material full slab depth is? So this expansion joint here. Does anybody know what that is?
I think the expansion joint is what happens when like weather changes, right? So you need something there to keep it together. Kind of.
Yeah, so you will sometimes need expansion joints because of the weather. Essentially, expansion joint allows for two individual components to move separately. So if we have a building concrete slab and a sidewalk that is also concrete, we want to allow for some room between them to move separately so that if they're moving differently, they're not causing each other to crack. So in this instance here, we have an expansion joint between our concrete slab for the interior slab, and then this sidewalk that is That is right here. So in between these two members, we have an expansion joint. Typically, you'll see like a 1/2 inch joint for most of your grading. Sometimes, depending on the severity of your members and how different they are moving. So an example is we did a garage where it is meeting a building, and the joint between them required to be 2 inches instead of one, or sorry, instead of just a 1/2 inch. And that's because the bridge with the building was moving a lot more than the parking structure itself. So you have to allow for additional room for movement, so that when that bridge does move, it's not pulling the structure away from the garage. So uh, here we are just calling out 21 to be that in between of the concrete slab of the building and the sidewalk here. 22 is pretty self-explanatory.
How do we
Oh.
actually draw the thing?
So
Do we just make a thick line?
no,
Or-
so if we go to our 4.51, you'll see in more depth what that expansion joint should be modeled as. So here I have it modeled as a 1/16 inch horizontal line filled regent pattern.
Okay.
And we're just making that 1/2 inch thick because that's what our notes specifies. And then the full depth of the sidewalk slab here. Concrete sidewalk, it's pretty self-explanatory. We have the sidewalk just being typically is specified by civil drawings. We have a gravel subbase, so you can see the gravel underneath. So we want to copy this note and place an arrow pointing at the gravel sub base below. I would also accept concrete sidewalk on gravel sub base these civil drawings so that you can combine these notes together instead of separating them in two different lines. So depending on how you want to organize those components, I'd accept either. 2-inch perimeter insulation at 2 feet minimum. This note is referring to this perimeter insulation here. So this filled regent that I have at a ortho crosshatch 1/32 scale. The purpose of the perimeter insulation is we're essentially insulating the perimeter of the slab to make sure there's no thermal bridging that's happening because we're above the frost line here. There's going to be some transfer of temperatures if we're not equal pressure. So we're incorporating a perimeter insulation that's 2 inches thick. So the thickness of this is 2 inches. And then it should extend 2 feet from this edge to the slab edge here. So it's 2 feet into the space, 2 inches thick, and it's extending down to the footing to prevent any thermal bridging into the space. Does everybody know what I mean by when I say thermal bridging? Question marks, maybe? Question marks? Okay. So thermal bridging, let's see if we can find a good diagram. Thermal bridging is the transfer of temperature through a material. So if there's a condition like a storefront that's not sealed properly, It allows for what's called thermal bridging, and it's essentially a transfer of temperature from either warm or cold into or out of your space. So a lot of times you'll hear people talk about thermal bridging, and they'll do like uh, a temperature reading of their house from the exterior. So it's just giving you these colors, like it looks kind of like a army night vision, where you're only seeing where you're reading like heat temperatures to get vision. But it's showing you where there's thermal bridging within your envelope. So if things aren't sealed properly or insulated properly, you're going to get what is called thermal bridging, which is the transfer of this temperature either inside your building or outside of your building. So we're trying to keep our building envelope as tight as possible where we need to, so we can control the environment, interior environment, make it as efficiently performing as possible. So that is what this is doing. That's what all of our rigid insulation and batt insulation is doing. It's preventing any thermal bridging through our envelope here. Does that make sense? All right. And then the last element is the reinforced concrete masonry footing. Again, this one, there's only so much more that we can point out or call out. So I'm sorry, we have note number 24 here and note number 25 here. We have our reinforced concrete here with our masonry footing above. So that is the assembly. A lot of these notes are continued over into the building sections. I want you guys to transfer the notes over to the other details and sections. And then as you make progress, ask me questions, because that gives you pretty much a majority of what the assignment is for where those text annotations go. I also encourage you to try and Google the information that I have laid out for you. It will ingrain in your head a lot more. If you're just copy and pasting, you're not going to learn from that. If you try to Google these components and understand what it is that you are calling out, you're going to better understand what you're detailing. To this day, I look at previous projects that we've done and see things that I'm not familiar with, and I look it up on Google to understand why we included it, what caused this situation to require this component, where other situations didn't require that component. When I don't find an answer, that's when I will go to a superior or somebody within my office to get a further understanding. But you'll always have somebody to go to in your office. If somebody pushes you away and says, "Don't ask me these questions," it's not a good environment to be in. But you should always try to find the answer yourself first before just going directly to somebody. And at least if you look up or try to look up the answer yourself and then go to the source for an answer, you can at least say, I was looking up this and my understanding is this, but I want to confirm with you. There would be a much more appreciated level of conversation when you show the effort trying to understand what you're detailing. All right, so I'm gonna let you guys run with this. I'm gonna make a plot real quick, and then I'll post this as an announcement so that you can refer to these numbers that I have just provided and start associating them to one another. Any questions while I'm doing this?
All right, go ahead.
Okay, so how do you get the lines to like be at a different scale? Because I put in the 1/16 horizontal lines and there's only one line, and I know there's supposed to be more, but I don't know how to get the scale to like shrink down.
Okay, so if we are looking at, you're saying like in this view, or are we looking at an enlarged view?
Oh, mute. Oh, sorry. Well, wait, what?
Okay. So, are we looking at the view in the wall section, or are we looking at it in the 5.1? So
It's
are we
in the
looking at,
wall. It's in the wall it's in the building section
okay,
right
so
now.
the building section, you're only gonna see one because this region is being, it's relevant to the scale of your drawing. So if you were to copy that same region and paste it in place in your section detail at foundation, you're gonna see more lines, and that's because we have a larger scale. Because, yeah, so because we're looking at a wall section or building section that is a 1/2 inch scale and a 1/4 inch scale, you're not gonna be seeing all the individual lines at this condition here.
Okay, well, this one only has two lines.
And are you looking at the
It's in my wall
5.1?
section.
Okay, so again, if you go to your 5.1 sheet and you're pasting in place on the foundation detail, so
Mhm.
you're going to 5.1, I think it is, should be what yours is. Can you confirm how many lines you're seeing?
It doesn't even have the bricks on it. Or like it doesn't load
Well, are
the
we looking,
details.
are we looking at the, well, so you have to copy and place. These are detail elements. So remember how I had gone through the exercise of once we copy, or once we draft in all of these elements, then we can copy all of them by selecting it all, going to filter, and then only checking the detail items, detail groups, and insulating lines. And then we
Okay.
copy and paste, and you want to hit the lines as well. So did you do this? Because
I have
because
not done that.
yeah, so anything you do in this section with detail lines or like detail items is only, this is, you're drawing this in 2 dimension and it's not going to show up anywhere else. So we need to understand the difference between modeling under the architecture tab and using annotations with detail regions and detail components.
Okay, yeah, because I assumed that it worked the same as when you build a
No.
wall, it shows up in all the views.
No. So that's why I was encouraging everybody to start with the wall section before moving onwards, because once you finalize modeling or drafting all of the components in the wall section, you will then be able to just simply copy all of these elements, filter out anything that's not a detail component. So we want to just hit insulation, detail items, detail groups, and then lines. We're going to hit apply. We're going to hit OK. So you can see
Okay.
certain things get highlighted in this instance. We're going to hit Control C, C as in cat, to copy. And then we go to, so I'm going to go in here and I'm going to just delete these so we can understand what's going on here. So we have lines, dimensions, detail items, apply. So you can see this is what it looks like prior to the detail elements. And then if I paste it in, this is what it should look like after the detail
So
elements.
you don't have to like find the little magenta square or anything? Like so just like usually when you copy something in, you have to like drag it and then place it somewhere. You
No,
didn't do that.
so yeah, in this instance, because we hit the Control C button, and then when you go to paste, you specifically say align to same place. Um, that will just paste it in the same location as where it is copied from.
Okay.
So, and you can see here, like, this is getting back to the level of detail. In my wall section, I didn't have that region modeled because at a 1/4 inch scale or at a 1/2 inch scale, you're not going to be seeing what's in between these two materials.
Yeah.
Whereas once I am in this is probably a 1.5 inch scale. Um, Let me go to my sheets. Sorry. So if I go to these, they are at 1.5 inch scale. So they're much more detailed. I'm able to see a lot more information. And this goes back to zooming in and zooming in until we're seeing as much detail as possible on how the GC should be constructing something. I don't want to be seeing an expansion joint in a building section because that's not what they're looking for. But once we get zoomed in enough to see a storefront sill, foundation slab edge, the rigid insulation at the slab perimeter, we want to be seeing the expansion joint material in this instance.
And do we just draw the like metal tube thingy? I forgot what it's called, but it's for the rainwater.
Oh, so yeah, you're the gutter and downspout. So
Yeah.
we are going to want to, let me save this real quick and then I'll
So we insert that from the Revit stuff.
no, so that is going to be drafted in via filled regions.
Okay.
I can zoom in though in a second. So if your firm is working with components, they may have specific components that do draft this in. Typically for our office, we have like a downspout family, but then outside of that, we are using filled regions to show the run of the head that connects the gutter or the trench drain to the downspout. So here, what I have is a solid white region that's modeled, just showing a gutter pan with some sort of with a grate that I have at vertical lines 1/32 inch. And then the gutter or the downspout is another solid white region that is connecting to that gutter. And then you can see a filled region of the concrete slab with the 1.5 metal roof deck that is a repeating detail component. And then we have the angle at the edge. So I'm sorry, Arson, I'm just seeing your message about copying and pasting the notes. Um, your you're welcome to copy and paste the notes. But what I was encouraging you to do is at least read what you're copying and understanding what it is that you are placing in there. Because I don't want you you're not learning anything if you're just having me feed you this information and then placing your notes where I'm telling you to. So I'm trying to encourage you to understand what it is you are detailing and why we're placing those notes.
Professor Rock.
Yep.
So if you go to the parapet all the way at the top, you see how the bricks kick out?
Yes.
So I tried doing that in my model, but since it's the linked model, I can't go back in and
Okay.
it.
So I was uh debating on that portion there because you're most likely you're cutting through the retail boutique, correct?
Correct.
So if we um when you take your section, are you seeing these brick projections in your
Yeah,
model?
those.
Okay, so your question is as far as like how to detail them or like how to place a component or
Well, no. So your example that you gave, you have the brick kick out up top. Would you like me to move my section to where you can see that?
No. So if you have an instance where you're talking about this
Yeah.
scenario here, uh, I want you to be modeling or detailing your section based off of the actual condition that is shown. So if you are working in the boutique or the office, I'm not sure if you see the projection in the office, but I don't want you to add in elements that aren't there. So in this case, what you would do is just create a brick coursing that uh, would look like that.
Yeah.
Sense.
All right. Perfect. Thank you.
Yep. And that's something that like you'll encounter again, like if you're given like a reference section or something to um bring into your section like with specific annotations and details, you'll have to kind of use your due diligence on what specific elements are. So looking at your section, Will, specifically, I can see that these two components here are row locks. So this is actually a 4-inch, should be 4 inches, and then um, 16 inches. So what really should happen in your instance, and we have to be sometimes creative with how we're dimensioning to these items, but this is more or less what you're aiming to get. So we have a 4-inch row lock, which is a brick that's turned. So instead of laying a brick uh, this way or this way rather, we're turning it on its side like this. So we have a 4-inch height rather than like 2 5/8, which is your typical brick coursing height. So that's what we're seeing here. And then if we were to look at our exterior elevations, which I don't have in this model, um, let me create a So when I'm looking at the coursing, you can see we have our regular modular brick, but then we have a row of coursing here and a row of coursing here that is flipped on its side. And this is 4 inches and 4 inches. Again, the rule of thumb when you're working with brick and masonry, we always want to be within a 4-inch or 8-inch coursing. If you're not, it's most likely due to uh, incorrect masonry coursing heights. I'm also going to be sending out a clip or image of the sign-in sheet that everybody signed up for last week. So just as a reminder of what time slots you guys signed up for. Plus, we have about 5 minutes left. Before we wrap up, are there any questions before we hop off? Once we hop off, I'll post that PDF with the numbers associated to them. I'm gonna post it as an announcement, just a heads up, so. All right, last chance for the night, guys. Are you all good?
I think I'm good. Thank you for
Okay.
going through the PDF. It was
Of course. Yeah. As always, if you have any more questions, just email me. I'll respond as quickly as possible. Thursday, just a reminder, I won't be in class because I'll be in Connecticut for a site visit, but we'll have our one-on-one meeting sessions. So just come prepared with any last questions you have that can be addressed before Tuesday's submission. And then Tuesday, I will be coming in to the studio and maybe I'll bring some goodies. We'll see. So I'll see everybody Tuesday if you want to come in. If not, I will meet everyone on Zoom at the meeting hours that we scheduled.
Okay, thank you.
Awesome. Thank you, everyone. Have a good night.
Bye, thanks.
Bye-bye.